Good afternoon, and in today's video we're taking a second look at the Ferguson TX10 that belongs to my friend Alex. We've also got Jan with us as well. We've actually taken the setup to his workshop, and we're taking a good look at it, and also checking the tube over as well, as the tube does take a little while to sort of brighten up when cold. So we're just going to give the tube a once over just to make sure that it is in good shape. Now, in the previous video I had a couple of comments, and probably the most useful comment I received was from a YouTube user called Old Gaming Fart. I would recommend checking out their channel because they do have a number of very interesting videos on there relating to sort of games consoles, etc. So certainly worth a look over there and seeing what they have going on. Anyway, so thanks to them, it did give us a bit of a head start on where we should actually start looking on the set for the particular sort of series of issues that we've got. If you remember from last time, the issue that we had was we could not adjust the picture width. However, a new issue has manifested itself since then, which is it's not maintaining field lock on any picture that isn't a test card, which I find really strange. If it's a static image, it's absolutely fine. If it's a moving image, it doesn't seem to maintain lock. So, given that we had a test card displaying successfully, the first order of business was to try and sort out that width issue. It is highly recommended that you do have a TX10 service manual, and you focus specifically on the section dealing with width control. So the width control circuit also seems to encompass the pin cushion control as well. So thanks to Old Gaming Fart, we checked the resistor R864. Now that should be 8.2 kiloohms, and it has been suggested that that can go high. So that's actually one of the TX10 stock faults. We did find that resistor was okay, but for sort of complete sort of troubleshooting, we did remove that resistor and replace it with another 8.2 k ohm resistor. There were a number of resistors around that particular potentiometer in the same circuit, which had gone either low or high in value. I can't remember the exact resistors themselves, but I know that we did have a few that had gone quite high in value. So those were replaced, and once those had been replaced, we did actually manage to restore complete control of width. We've also improved control of pin cushion. Now, the next issue that we wanted to investigate was this pretty tricky one as regards the picture stability. So I had a look at some of the stock faults that the TX10 exhibits. I've got a copy of Television magazine from about 1989, if I remember rightly, which covers a number of the TX10 stock faults and obviously servicing TX10. I couldn't see anything on there that suggested that there were any issues with it's not field fold over, it's not even field rolling, it's where it's sort of almost sort of, if you have a picture on there, it's almost sort of running to the side. So it's almost like a horizontal problem rather than a vertical issue. Now, on this particular chassis, the field control IC is a TDA 2576A. There were three different chips that we used. There was a TDA 2576, TDA 2576A, and a TDA 2578A. Now, there are a number of resistors that you need to check in conjunction with that particular chip. We did have one resistor that had gone high in value, but unfortunately replacing that resistor did not seem to did not seem to resolve the issue. Pin 1 of the chip, according to a chip schematic that we managed to find, which was in Polish, but using the Google Translate facility on my Android phone, I was able to, over a printout that we had, I was able to translate a lot of the Polish into English. So I found out that pin 1 should have 12 volts going to it. So we checked the supply to pin 1 and it was a firm 12 volts. There was no problems with the supply to the chip. Pin 8, from what we could ascertain, should have a sandcastle pulse, and or is it pin 1 should have the sandcastle? There was one of the two that should have a sandcastle pulse, or and it was, I think it was pin 1 that we did see the sandcastle pulse, so we had good input into the chip. However, on the output side, we weren't really getting any sort of consistent pulse coming out of the chip. If I recall correctly, we should have sandcastle coming out, but we didn't have that. We used, after a bit of manipulation, we managed to get the oscilloscope working in order to detect what was coming off the chip. There is a test point on the chassis marked sandcastle, which does allow you to try and get a reference sandcastle pulse, which we've managed to do. So we were able to calibrate the oscilloscope, and we were able to output the relevant pulses so we could actually see what was going on. However, the chip was really sort of giving us a number of very sort of unusual readings. It didn't seem to be sort of playing ball exactly. So we've put another TDA2576A on order, and once that comes in, we'll just be replacing the chip and seeing if that improves the set performance. Fingers crossed that it does, because it seems to be one of those issues that's a little bit unusual. Thankfully, though, we did manage to repair the width issue, but obviously this new issue seems to be sort of causing us caused us sort of a fair amount of head scratching. So at that sort of particular point, we decided that replacing the chip would probably be a good idea. They're only £4.50. Doesn't take long to unsolder and resolder, and it's just one of those things that would sort of probably be a good thing to do, given that we couldn't sort of get a consistent reading out of it. As I say, the voltages going into it seemed absolutely fine. We had good pulse going into it as well, a good 12 volts going into it, but we didn't seem to have any kind of sort of consistent output. What is interesting is on pin 8, I think it is, the voltage changes if you select channel 8 on the channel selector. And that's because the output of the chip changes to suit a VHS input on the RF socket, or VHS or Betamax, basically a VCR input. So we did notice a change in voltage, so it did seem to be switching internally, it did seem to be working. If anyone has any sort of information as to why we may get a picture that sort of rolls almost diagonally across the screen, but we seem to have absolutely no problems when we're working with just a static test card input, again via RF, I would be interested to know. So don't feel shy. Feel free to leave some comments in the comments section. This whole process has actually been sort of my first proper troubleshooting session with a TX10 chassis. I've usually sort of stuck with Sony's previously, so it was interesting to sort of look at a different chassis that I'm used to dealing with, and also sort of a completely different set to what I'm used to dealing with. Actually far simpler, certainly sort of far simpler than the Sony chassis that I've sort of dealt with in the past. But then again, the Sony chassis I've dealt with in the past they've actually been newer, and they've had a far wider range of inputs. When we sort of parked the troubleshooting this particular set, we decided to take a look at the tube. One of the things we noted with the tube was that it was so that it seemed slow to warm up. It would sort of be quite dim for the first couple of minutes, and then it would sort of gradually come to life. We actually discovered that the tube itself has got almost perfect emission across all guns. So red, which is usually the one that seems to go first, had very good emission. Blue was also good, and green was also good. We also discovered that there were no shorts across any of the grids within the electron gun assembly. Again, very good. So just basically pointing to the fact that the tube on the whole was in a pretty good state overall. When turning on the tube tester, we needed to make sure that it was set to test rather than rejuvenate. Obviously, if you set it to rejuvenate immediately and you plug it in and turn it on, you're going to start rejuvenating things that you don't necessarily want to rejuvenate, and that will just trash the tube effectively. You'll be left with an even deader television than you started up with. So we're just going through the process here. So there's this adapter board that fits onto the neck of the tube, and the board itself isn't actually that heavy. Although it is sort of metal cased, it's not actually heavy. It doesn't seem to put any undue stress on the neck of the tube itself, which is good. And coming up to take a look at the gauges themselves, or the gauge itself on the tester, you can see that on red we've got in the green section, which is good, blue is good, and green is good. And there were no shorts when we were obviously testing for shorts there across the relevant grids. And if you turn off the tester, the emissions actually go down very slowly. They don't immediately drop to the floor. That's, from what I've been advised, is the sign of a good tube. If you turn it off and the emissions drop steadily, then you've got a good tube. And we found that they were dropping steadily across each gun. Anyway, that's the end of this particular video. It'll be interesting to see if that chip does fix the issue. If you found this video interesting, don't forget to hit that like button, and also consider subscribing for more upcoming fascinating hobbies. Thanks for watching.